This is Dr.a Govardhan, the Professor and Dean, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I am covering modes and mechanisms of heat transfer in the subject heat transfer of 5th semester students. The course overview of heat transfer is the flow of thermal energy due to the temperature difference and subsequent temperature distribution changes, commonly measured as heat flux. This course focuses on heat transfer modes such as conduction, convection, and radiation, boundary conditions, one-dimensional steady and unsteady state condition, heat exchangers, mass transfer mechanisms, which are applied to modern aerothermal systems for designing higher thermal efficient systems. Thus, there is a great relevance for this course in modeling heat exchangers, heat treatments of fins, and complex mechanical systems, and create a scope for the graduate studies. Course objectives. The students will try to learn the governing equations and performance relations of various modes of heat transfer using 3 types of coordinate systems. The second one, the concepts for validating heat transfer parameters during internal and external flows based on non-dimensional numbers and convective mode heat transfer. Third objective is the performance and analysis of heat exchangers for real-time applications using various methods and indicators such as LMTD and NTU, etc. The fourth object is the design methodologies for enhancing heat and mass transfer among wide variety of practical engineering problems. Course outcomes. After successful completion of the course, the students should be able to solve problems involving steady-state conductions with and without heat generation in simple geometries. Second, CO2. Make use of concept boundary layer theory for derivation of empirical relations related to the characteristics of a boundary layer. Third outcome, utilize the principles associated with the CO3, utilize the principles associated with the convective heat transfer to formulate and solve the heat transfer coefficient for various cross-section areas. CO4, identify the physical mechanisms involved in radiation heat transfer, boiling and condensation, for giving various correlations applied to heat exchangers, boilers, heat engines, and etc. CO5, analyze the limited LMTD and NTU techniques for tackling real-time problems using thermal analysis and simulation and cost optimization of heat exchangers. CO6, analyze the various mass transfer correlations for comparing the momentum, heat and mass transfer analogies. The syllabus for the heat transfer is divided into 5 modules. The first module is related to introduction to heat transfer and conduction. The second module is free and forced convections. Third module is phase change heat transfer heat exchangers. And fourth module is radiation heat transfer. Fifth one, mass transfer. Okay, the textbooks are Heat Transfer, a Practical Approach, Tata McGrath Limited, written by Yunus A. Senjal. Second one is R.C. Sachdeva, Fundamentals of Engineering, Heat and Mass Transfer, New Age, New Delhi, India, 3rd edition, 2012. Again, three reference books also identified. One is Holloman e-transfer, Tata McGraw-Hill's Education Private Limited, New Delhi, 10th edition 2012. And the second one is C.P. Kodandaraman, Eton Mass Transfer Data Book, New Age International Publishers, New Delhi, 9th edition 2018. And the third one is Ghost Dustidar e-transfer, Oxford University Press, second edition 2012. The introduction to e-transfer. The temperature is the intensive properties that indicate the thermal state of system or a body. The temperature is the measure of internal energy possessed by the body or the systems and gives the directions in which energy in the form of heat will flow. It is generally denoted by T, and the following scales are used to measure the temperature. Generally, here the word is given, the temperature is the measure of internal energy. When the temperature is more, the internal energy possessed by the system is more. And also, based on the temperature, the heat energy always flows from higher temperature to lower temperature. These temperatures are commonly measured in three scales. First one is Celsius, it is also called centigrade now. According to this scale, the freezing point of water is assigned a value of 0 and boiling point value is 100. It is represented by degree centigrade. The second one is the Kelvin scale now. According to this scale, the freezing point of water is assigned the value of 273 and the boiling point is 373. It is represented by K. That is, it is similar to the Celsius centigrade scale, where 0 is treated as the freezing point of water, but here it is equivalent to 273. The maximum value is boiling water is 100, here it is 373. The difference between 273 and 373 is 100. That is both the scales, that is Celsius, the Kelvin scales, from 0 to 100 divisions are there, but marking with 0 to 100 in Celsius, and in the case of Kelvin scale, it is marked which is 0 earlier, it is equal to 73, and the boiling point is with the 373 now. Fahrenheit scale now, according to the scale, the freezing point of water is assigned a value of 32, and boiling point of water is assigned 2012. That is the divisions between 2212 and 32 is 180. So, freezing point to boiling point of water is divided into 180 divisions in case of Fahrenheit scale. It is represented by degree Fahrenheit. Since these three scales are prepared based on the freezing point and boiling point of water, hence these three are having the relations by using these equations. It is equal to C by 5 equal to F minus 32 by 9, which is equal to K minus 273 divided by 5 now. Or it is also can be written as now C by 100, it is equal to F minus 32 divided by 180, it is equal to K minus 273 divided by 100. Yes, by using these equations, we can convert the temperature of one temperature which is measured in one scale to another scale by using these equations. Heat is a form of energy which is always in a transit nature, and it flows from one point to another point, or in other words, it always flows from higher temperature to lower temperature of the body. The heat may be defined as the flow of energy from one body to another body by virtue of temperature difference between them. The net flow of energy always occurs from higher temperature of the body toward the lower temperature of the body, and this flow heat stops the movement temperature of both the bodies are equal, or in other words, when these two bodies reaches thermal equilibrium, then the flow of energy stops now. According to the international systems, the measurement of energy is measured as joule only. 1 joule is equal to 1 Newton meter. Sometimes it is also measured in kilocalories, which is equal to 4.182 into 10 to the power of 3 joules. So, or the energy meters is also there now. Sometimes it is also measured in kilowatt hour, that is which is equal to 3600 joules. So the difference between thermodynamics and heat transfer. The thermodynamics subject already studied in the third semester, and heat transfer in fifth semester. The main difference between thermodynamics and heat transfer is the thermodynamics is the science which deals with the equilibrium states and change from one state to another state during the process. But the heat transfer is a non-equilibrium phenomenon as it occurs when thermal equilibrium is disturbed. The thermodynamics is a science which deals with the amount of heat transfer during the process, or just it changes one form to another form so that some amount of work is also obtained. But in heat transfer is a science that deals with the rate as well as mode of heat transfer during the process. The thermodynamics is a science which deals with the amount of work done during the process, but heat transfer indicate the temperature distribution inside the body. So in the previous we discussed the heat transfer always taking place from one body which is having higher temperature to a lower temperature. Here three types of modes of heat transfer is taking place now. In general, one is conduction, convection and radiation. This is nothing but happened only due to the temperature difference between the two regions or the two bodies. And heat transfer is the study of transmission of thermal energy from high temperature region body to a lower temperature body on account of temperature difference. The rate of heat transfer is directly proportional to the temperature difference between the exchanging regions of the bodies. Here let Q is representing the amount of heat energy that is transferring from one body which is having higher temperature to a body having lower temperature. It is always proportional to the temperature difference between the two bodies, that is T1 minus T2. If the temperature difference between these two bodies is more, the amount of energy that flows also increases. Once the process of heat energy is complete, it is stored in one or more forms of energy such as potential, kinetic energy and internal energy. And one more is the procedure of heat transferring is completed or the stops when the two bodies having thermal equilibrium. That means the temperature reached by the two bodies are equal. The transfer of heat between two regions of body maintained at different temperature can occur in three different modes, namely conduction, convection and radiation. In conduction and convection modes, the heat flows from higher temperature to a lower temperature region. But in radiation, the transfer of heat takes place from both the bodies towards each other However, the net heat transfer is always from higher temperature body to a lower temperature body. Here example, conductions. Here conduction is the process of heat transfer from high temperature region to lower temperature region within a body or between the two bodies which are in direct physical contact. Here I am taking here the example is there. The object is represented here now. It is there. The heat transfer is here one side of the body is exposed to higher temperature, or in other words, the heat is input at this side now. The heat energy is flowing from higher temperature of the body to the lower temperature. That is this other side of the body. So the heat transfer which is taking place within the body from higher temperature to lower temperature or between the two bodies which are having physical contact, the type of flow of energy or heat transfer is called conduction. In conduction, the heat energy is transferred due to exchange of molecular kinetic energy. The temperature along the entire length of the body becomes equal and has been depicted in figure number 1. Here the heat energy flows from a body at higher temperature to the lower temperature. It is only because of molecular kinetic energy. When both sides of the body having equal in temperature, there is no kinetic energy, molecular kinetic energy, that is both are equal, hence the transfer of heat energy stops or the body is said to be having thermal equilibrium in entire its volume. The heat transfer by conduction is determined by thermal conductivity and the temperature difference. Here, if Q is representing the heat flow energy from one point in a body to another point or from higher temperature to lower temperature, it is a proportional to the temperature difference between the two locations, or when the heat energy is flowing from one body to another body, it is called the temperature difference between the two regions or two bodies. Generally, it is represented as a T1 and T2 and also proportional to the thermal conductivity. It is the property of the materials. One-dimensional conductions, the rate of flow of heat energy can be described by the Fourier's law, which is written as Qx is equal to minus of Ka dt by dx, where K is representing the thermal conductivity of the materials. Generally, it is measured in terms of watts per meter degree Kelvin, and Qx is the quantity of heat flow in watts, and A is the area of the cross sections in which direction the heat energy is flowing, and dt, it is the temperature difference between the two regions, and dx is representing the length of the object or thickness of the object or the distance between the lower temperature to higher temperature point to lower temperature point in a body, or the two bodies are having contact. It is the difference between the higher temperature body to lower temperature of point in another body. The second one is the convection process. The convection process generally occurs in fluids as well as the gases, and also from liquid to the solid surface when they are having in contact. It is only because of temperature difference existing between them. The heat transfer by convection occurs under the combined action of heat conduction and mixing motion. Here the example I am taking now, a vessel is there. It is filled with the liquid as shown in figure. When it is heated at the bottom of the vessel, first the conduction process is taking place to transfer the heat energy from lower part of the vessel to the inside by using the conduction process. After that, from the inner surface of the vessel to the liquid which is having in contact, again convection process taking place. That is from solid to liquid. Again from the liquid lower surface to higher surface is also taking place now. Generally, when the liquid which is having contact with the hot body, the density of the liquid is decreases. Hence, it is tried to move just in upward directions. At the upper level, the temperature of the liquid is lower, or in other words, the density possessed by the liquid at upper surface is very more, hence it moves in downward directions. So by moving the liquids up to down and down to up, the heat energy is transferring from one point to another point within the liquid. This process is called here convection process. The upward movement of hot fluid particles and downward movement of the cold fluid particles is called convectional currents. If the conventional currents are set up only due to the density differences, then the heat transfer process is termed as natural or free convections because for the movement of hot fluid to upward directions and lower temperature fluid which is there at the top to move downward directions, we are not at all using any external mechanisms. Hence, it is called natural or free convection process for flow of heat energy from one point to another point. If the conventional currents are caused by some external means such as blower, fan, pump, and etc., then the heat transfer process is called forced convection. The convective heat transfer rate is governed by Newton's law of cooling, and it is expressed as Q is equal to H into AS Ts minus Tf. Here, where H is equal to convective heat transfer coefficient, generally it is expressed in watts per meter square per degree Kelvin. A equal to heat transferring area, which is expressed in square meter, and Ts and Tf, these are the temperature of the surface and the fluid respectively, and expressed in Kelvin. Here, this equation is applicable here now to find the flow of energy from the surface of the hot body to the liquid which is having in contact with them. The radiations. The heat exchange between the two bodies are the mediums which are separated and not in contact with each other is called radiation heat transfer. First, we observed in conduction process, the heat transfer is taking place from one point on the solid body to another point on the side by the kinetic energy of the molecules, or the heat energy which is flowing from one between the two bodies which are in contact with each other is called air conduction process. In second case, the convection process, generally it is happening by the movement of the liquid particles because of its density differences. The heat is transferring one point to the liquid to the another point, and also from the hot surface of the body to the liquid, that is called a convection process. In radiations, the heat energy is flowing from one body to another body, even though they are not having any physical contact, they are separated with each other. Then this process is called radiation process. The radiation process, heat transfer does not require presence of any intervening medium between the two bodies and takes place most effectively in vacuum. Example of radiation of heat transfer is the energy received from the sun to the earth as shown in figure number 3 now. The thermal radiation is the energy emitted by a body in the form of electromagnetic waves due to changes in the electronic configurations of the constituent atoms of the molecules of the body. When electromagnetic waves in contact with the body, the energy is transferred to the body as the thermal energy, which is partly absorbed, reflected, or transmitted. Energy emitted per unit area as a thermal radiation is called emissive power of a body. The maximum energy emitted as a radiation by a body at a particular temperature is governed by Stefan Boltzmann's law, and which is expressed as EB is equal to sigma A T to the power of 4 now, where sigma is representing Stefan Boltzmann constant, which is equal to 5.6 into 10 to the power of minus 8 watts per meter square per fourth power of degree Kelvin. EB representing energy emitted per unit time. Generally, it is expressed in watts. A is equal to area of the cross section, and T is the absolute temperature of the body, which is expressed in kelvins. So, in order to cover this topic, these are the textbooks I referred, and web content also followed, including e-textbooks. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.